Here we are, the next video in the series where we're going to be machining the block. We are going to bore the cylinders oversized to the first oversize available, which is going to be 20 thousandths of an inch. And then we're also going to surface the block. So the process for this is the block is actually mounted onto my CNC machine where I can machine one bank at a time. And the first step that we're going to go through is machining the cylinders. Now I've located the cylinders. What I've done is I've located the front cylinder with the probe. And from there, each cylinder is going to be offset by 4.4 inches. And that's the standard cylinder offset for all the GM LS and LQ and LM and LT engines. 4.4 inches is their cylinder offset. So all I have to do is just measure for the first one and then start the program that bores the first cylinder and then bores the second, the third, and the fourth. Now the tool that I'm going to be using to bore it is using a single cutting point, and it has a small triangular tool bit on the end of it, and that one corner of that tool bit is what's going to be machining the cylinder, kind of like machining brake rotors, but instead of the rotor spinning, the tool bit is actually spinning, and it's going to be plunging down into the cylinder and machining the cylinder out to about, we're going to shoot for about 15 thousandths of an inch so that I can do the final cylinder sizing in the hone. And when I go to honing, that's going to be not only setting the dimension, the shape, but also setting up the crosshatch so that oil can help the piston. Oil can get up into between the piston ring and the cylinder wall and let the piston rings actually seal compression and combustion. So let's get a close-up shot of the setup here. Now we're on a close-up view of the actual tool. So this guy spins around. It's going to spin at about 600 RPM. And the insert that I was talking about, the cutting insert, is this triangular piece that's actually bolted in with an insert screw into this holding tool. Now this tool has got a locking screw here. And then on the back side, this is the dial. So as I screw this in clockwise, that's actually going to push this tool out this way. So I have right now already touched off the cylinder to the tool. So I've had this down inside the cylinder of the engine. I've had it down inside the cylinder of the engine and just touching it off just to make sure that it just scratches on it. And then from there, I'm going to add my first cut. And I'm going to do, let's say we'll do about 15 thousandths of an inch. Now this is set in metric, so I just have to do the conversion. And I let it run. So there we go. Now, a quick rundown on this program. So this is my CNC, this is a control system made by Centroid. It's an older system, but it works great. So I was going to show you the program. So let's go to the program here. And this is what they call intercon. It's conversational programming, so you don't have to use like hard coding the G code, or you don't have to use a CAM software package to generate the code. Now, because this is just a point to point, where it goes from our 0, position to 4.40 and then 8.80, those are just positionals. All I need to do is tell this program where my start position is and how far to each one. So our first line up there is just the program information for this intercon program. The next piece of information is what the tool is, and in my machine it's tool 15, and it's going to run at 600 RPM. Go down to the next one. The next one is the actual boring procedure. And it has it starting off at 0, 0, because this is a Cartesian coordinate system, just like on graph paper. My first cylinder is 0, X and 0, Y. Now, if we go down here, the increment, this is what step is it going to be? Is it going to be stepping in the X direction, the Y direction, or both? So I have it just stepping at 4.400 inches in the X direction. The number of holes, there's 4 in each bank. Our clearance height is how far will that tool come out of the cylinder before it moves to the next one, because you don't want it to try and move while it's in the cylinder. Rapid to depth, so when it comes in for positioning, where's it going to move quickly and where's it going to stop to? And then our hole depth, how far down in the cylinder is it going to bore? I need to make sure that I bore it all the way to the bottom of the cylinder and past it if possible, because I don't want to have a lip left on the bottom. So we'll go ahead and just escape out of this. The program is already written and it's ready to go. So we'll go ahead and hit cycle start. All right, so I need to set the actual cut, because this is 0.01 millimeter on this dial. I want to cut out to 15 thousandths of an inch, so that actually comes out to 37.5 marks. So if I just put my tool in here, get it in there, and let's see if we can focus better. And I'm going to dial in 37.5 marks. So there's 10, 20, 30, 35, 36, and 37. And we're set at 15 thousandths of an inch roughly. I'm going to tighten it up, and we'll start the program. You hit the bottom of the cylinder, it stopped, and it's just going to reverse back out. And this is a boring procedure. Not very exciting. Get it? When it comes out of the cylinder, it's going to move over 4.4. Well, to go up 100 thousandths, then move over 4.4. All right, it's out. And it starts on the next one. The nice thing about a machine like this is that I don't have to stand here and babysit it once the program is proven. I can go do something else. I can check on things in the washer, work on a cylinder head, just sit down and, relax. Now, granted, this program only takes about 6 minutes, but it's still, time that I could be doing something else. going to do the measurement on the bore, and after this, we're going to step over to machining the deck of the block. There it's out. The next measurement we need to do on this block is to check for warpage of the deck. So to see if this deck has any dip in the middle or if there's any twist to it. I'm going to machine the top of the block anyway, just as a matter of course, because I like to have a good flat surface. But to do this measurement, you do need a precision straight edge. So this straight edge is a 36-inch straight edge, and this bottom edge of it has been machined in such a fashion that it's pretty straight across its length, or pretty flat across its length. Now the way you do this is you're going to set it up on the deck like this, and this is the same process for a cylinder head. We're going to try and stick a feeler gauge. So this is the 2/1000 feeler gauge, and I'm going to try and stick it underneath the straight edge. If I can't get it under the straight edge, that means whatever clearance there is, if there is any, is less than 2/1000 of an inch. Now I don't want to try and stick it under there and try and drag it out. That's not how feeler gauges are really designed to work. You try to put it in. If it doesn't go, it's smaller than that gauge. So let's try 1.5 on this one to see if it will go. So here we are at 1.5. Try and stick it underneath there, and it's not going. Okay. Now we're going to do this in at least 3 different positions. So I have now it's lined up down the center of the cylinders. The next one I'm going to do is line it up on a diagonal of the cylinders. Okay, still can't get it in there. Means this deck is starting to look like it's pretty straight. Oh, there we go. Nope, still not going in. And I'm going to go through the other diagonal and try and get it underneath the edge of the straight edge. All right, so again, I'm going to put the straight edge down the length of the cylinders down in line like this across the center lines of the cylinder. I'm going to take my feeler gauge. I'm going to try and stick it underneath right there. I'm trying to stick it underneath the feeler gauge here. Nope, it's not going, it's stopping. Then go to the next one. Not going there either. And what I'm looking for is for the feeler gauge to go underneath. What I'm looking for is for the feeler gauge to go underneath the straight edge. Now I'm making this fail, so I'm going to take this feeler gauge, and you're going to see that the feeler gauge, it goes underneath. Now because I've shimmed it up on one end, that's not what we do. So I've shimmed it up on one end with a piece of paper towel just as a demonstration to see that I can get the feeler gauge underneath the block. So that means that this section of the block right here is lower than the sides next to it. So let's try and put it in here to see if it's still the same. There, it still goes in there. And does it go in over here? Yep, still goes in there. And we're looking to see that it goes underneath. It's going underneath the straight edge. Okay, the only reasons this one's doing it is because I've shimmed it on one end for a demonstration. Now, if we measure a cylinder block and it does have excessive warpage or a cylinder head, it needs to be surfaced, or in some cases, if it's an overhead cam cylinder head and the top of the cylinder head is also warped, that cylinder head might need to be straightened. And that's a process a machine shop would perform for you. So the next thing I'm going to do is mount up the surfacing head. So here's the surfacing head. On it has, let me do this. So here's the surfacing head. It's going to mount up in the spindle with this right here. This is our Cat 40 taper. And it has one cutting insert, and this is going to rotate around looking down at it counterclockwise. If we take a good close look at that insert, let's see if I can get it. There you go. So here's a good close look at the insert. This is CBN. It's a cubic boron nitride, and it's a really hard material. And just this little insert, it's a 1/2 inch in diameter, is what's going to cut the top of the block. And it's going to take very small cuts, but a lot of times as it traverses down the length of the cylinder head. So let's go ahead and mount this up. You see it's going to spin in this direction there. And I've got to set up the program, and when I come back, it'll be ready to cut. All right, so we're ready to surface. So the machine's going to go up to the home position, then come back down to 2/1000 of an inch below the deck of the block. I like to take thin cuts on this because, one, I got time and I don't have to worry about production. I'm going to take 2/1000 of an inch off the top of the block, and that's going to help show that if the block has any high spots or low spots, because if it cuts a section, it was high. If it doesn't cut a section, it was low. So let's go ahead and get this going. So the spindle's running at about 700 RPM. You can see it coming down nice and slow. Once it gets down to position, the block is going to traverse off to the left. And it's moving at about 5 inches a minute. You can see it's starting to not cut right in that area. It's actually starting to miss here in the middle. Looks like it's pretty much missing it all together. Now it's starting to come back in down around the cylinder. You can see that shiny spot. It's starting to cut again. Now I know this block is level because the bar that I have mounted to is perfectly level and trimmed on the machine. So that means the mains where the block is mounted is level too. So you can see I have this aluminum ring right here, and the bar, this is a 2-inch turned, ground and polished bar, and it has that aluminum ring, one on each end, and that's locating the block on the main center line to this bar. Now this bar is level, and it's also true in the machine in the XY positioning. So that means that block is level. Now what we're seeing what we're seeing when it stopped cutting is actually a high spot on the block over here compared to low spots over here. And because it's still cutting, that means there's actually some distortion in the block. Now remember, when we were trying to measure this, we were measuring with 1.5 thousandths as our smallest measurement. What this is doing is it's capable of cutting a few 10,000ths of an inch at a time. So if it's still cutting, which it is, it's got a little bit of cut going on right now. Looks like it's happening somewhere near the cylinder. It's still cutting it. That means it's cutting out deviation that we weren't able to measure with the straight edge. It's not cutting anymore, so I'm going to go ahead and cancel this program so I can just get it running on the next pass. Go ahead and change the program. I'm going to have it go down another 2 thousandths of an inch. So that was 2 thousandths. Now we're going to go down to the 4 thousandths level. So first we went down from 0 to negative 0.002. Now we're going to go to negative 0.004. So it's going to start all over. So real quick before we start cutting again, I want to go ahead and do a quick view of this block. So we can see over here on this end, the block is really nice and shiny. It's been machined down. Now there's some marks right here, and that's just from a back cut, and that's normal. I like to run my machine in a certain way. Then we come around here, we can see that it was cutting here just fine. And then it stopped cutting through here, so that meant this section is lower. And then again, this section is lower here. Of course, it started cutting again. So that meant this piece right through here, this whole section, is depressed. It's lower. It's lower than this section and this section and this section over here. And we see it started cutting again across this section, cutting again, and then it stopped. So this whole corner of the block right here is lower than the rest of the block. But it still has some very small witness marks from it actually trying to cut, so that meant it probably had about 1 to 2 10,000ths of an inch engagement. So this time around, if it doesn't cut the whole thing, we're going to see a progression of the sections that haven't been cut actually getting cut. So it almost got it, still got a couple of spots that are low. But I surmise another 2 thousandths will take care of everything on this block. That means we would have machined off 6 thousandths of an inch total. So I'm going to go ahead and cancel this cycle. We're going to take a close look at the top of the block, and we're going to see so we're going to move the block back into position where we can see it, and we're going to see an issue that shows up that's not necessarily going to be measured by warpage. We're going to see gasket fretting. Now when we look around the cylinder, we'll actually get to see what's called fretting. So where the head gasket ring, let's see if we can get a shot of that. How can we get in there? There's some right there. There we go. So that ring right there, that's fretting from the head gasket. Of course, it could also be corrosion, but when we have this section right here, this line, that means it's not cutting. That line is actually lower, and that's from the gasket pressing into the deck of the block. Now, because the block has been machined on each side of it, this is probably very, very shallow. But when we measure the warpage on the block, we're really not taking into account any fretting from the head gasket. And what that is when the engine's running, the cylinder head sitting on top of the engine, and it's basically just kind of shuffling around. It also expands and contracts as the engine gets hotter and cooler. And that movement back and forth, you know, longitudinally and transversely across the deck of the block causes an embossed section of the head gasket to kind of work its way into the deck of the block, and that's fretting. So we do need to worry about that when we're trying to consider the condition of the top of the block. Like, it may not be warped, but you might have gasket fretting that is, you know, that might be 20 or 30 thousandths of an inch deep. It means that needs to be machined, and that's actually really deep, considering if it was that deep. 20 to 30 thousandths is pretty deep. So I'm going to set it up for another 2 thousandths off the top of the block, and that should clean off the top of this deck enough that we'll be able to go to the other side, and we're starting the process again. I won't have you watch the whole other deck. It's all the same thing. I just have to pick the block up, rotate it around so they can do the other side. So this will be the end of block machining for rough boring and surfacing the block. The next video will be the honing, but that will be a separate video altogether. All right, looks like we're all done. We just have a couple spots where a little bit of corrosion was left, but since the gasket will cover that, it won't be an issue. Let me jog it out, and we'll get a good close look at it. We can see we've got a nice machine surface. Now this stuff right here is what's called back cut, and that's because I run my milling machine a certain way, so it just happens that way. That's all. I like it. I think it looks good. We have it machined all the way down, and you see we have, so we've got this section right through here. This is where corrosion just made it through. On the head gasket side, it won't be a big deal at all. I can barely feel it, and the head gasket will just encompass that anyway, so we don't need to do anything else. But that's rough boring and surfacing of the block. So step 2, well, the next step would be to do the other side, and it's basically all the same process. Just have to pick up this big heavy ass block, so I can flip it around and put this deck up here and that deck down here. So we'll see you later.